Hello everyone, myself Kumod. I am a data science trainer at Brillica Services, and today we'll be covering a new topic in Python, which are typecasting. Basically, it's typecasting refers to as type conversion, which means converting a data type into another data type, right? So let's understand what are typecasting. If I move to the next slide, and in this we can find what are typecasting, right? If we are to define what is typecasting, then it can be defined as typecasting means converting one data type into another, right? It suppose we have integers numbers and we want to convert in the float numbers, then that process is referred as typecasting, right? For example, converting a string 10 into integer 10, right? It can also be done. So, what are the types of casting? There are two different types of typecasting present in Python. The first one is implicit casting, which means they are basically done automatically by Python when performing operations. Okay, and explicit typecasting basically means those type of typecasting with where we have to declare, like we have whether we have to tell the Python like do convert this number into integer, then convert this number into float, or convert this text into string, or convert this into boolean. When we have to specify by our own, then that type of typecasting process is referred to as explicit casting. But if something is done by Python itself, and it's referred as implicit casting. Okay. And why casting is important? Because it ensures the correct data type for operations. Like suppose if I have to perform an addition between two numbers, then if those two numbers are not in the form of either integer or float, then it will raise an by misleading value, right? Suppose if I use 2 in the form of string, then 3 in the form of string, then it will return me 23, not 5. Just let me show you an example. Suppose if I write x equals to string 2 and z equals to, if I write 3, right? Let me 3. And if I print x plus z, then it will return me 23, not 5, because these are strings. In strings, if we use the plus after, then the concatenation is performed, not the evaluation. That's why the correct data type for the specific operation is very crucial for changing, right? Let's move to the different types of conversion. Explicit casting, which we will learning today's class, because implicit casting is something which Python does it automatically, so we don't have to figure it out like what will be converted, because Python is so advanced, then it basically designs the correct data type according to the need, okay, or according to the operation output, right? But about the explicit casting, we have to learn, and we have to know what kind of performance which we can use and what we can't, right? So moving to the next slide, here we can understand working with data type conversions in Python. Okay, the first one is integer conversion, right? It can be defined as convert values into an integer. Decimal numbers are truncated, right? And strings are representing positive or negative whole numbers can be converted, right? Or booleans are also convertible, right? Suppose if I write, let's give me a title for integer conversions, right? If I write like this, and suppose the first point was decimal numbers are truncated, right? So if I write x equals to 5.5, and if I check print x and type of x, then it will return me float. Because by default the data type Python decides in this are float data types. That's why suppose if you want to convert this into, if I want to declare that store this in the form of integer not float, then we have to specify int before 5.5, and if I now run this, then it is converted into integer, and integer only stores the whole numbers. That's why for 5.5 was truncated into 5. So truncate basically means no rounding up, just truncate and extract the number before the decimal places, right? Suppose if I write 5.7, then again it will return 5, not 6, because it is not rounding up, it's just extracting the number before the decimal point. If I write 50, then it will return me 50. Okay, the first one. The second point in that was strings representing positive or negative whole numbers can be converted, right? Suppose if I write x equals to, if I write in strings for 3, right? And if I write z equals to minus 3, right? And now if I check print x and type of x, right? And if I check print z, and if I write type of z, then it will return me 3 class 3 minus the class 3, because I have used quotation single quotes for storing the number. this is a number, but it is stored in the form of text. That's why these are default as a string, right? So to convert this in the form of integer, we just have to specify the integer function before the number. I write int over here, and if I write int over here again, right, and then it will be converted into integers. Okay. Now the third point about the integers, like boolean are also convertible, which means boolean values can also be converted into form of integer, right? If I write x equals to true and if I write z equals to false, right? These are the only two possible values that can be classified for boolean values. If I write copy this, then if I run this before conversion, that it will return me bool. But if we want to convert this in the form of integer, then we can just specify this, and again if I specify this, right, then it will be converted in the form of integer, and the first one return 1, the second one will return 0. Okay. Moving to the next, which will be float conversion. Just let me give you an heading, which is float conversion, right? Float conversion. If I give this one heading, right, and let's go back to the slide. Float conversion basically means converting values to a floating point number. Integers, boolean, string representing whole or decimal numbers can easily be converted to float. Just let's take an example of this, right? The if I write this and if I specify float over here, right, and if I float, then boolean values are also converted, and the 1 will be converted to 1.0, the false will be converted to 0.0. Okay. If I copy this one for the string which we did, and if I write 3.3, right, if I write 3.3 and over here I write 3.4, and if I change integer to float, and over here if I change integer to float, then it will return me class float and float. Okay. Now if I use any integer number as well, just write, suppose if I write 15, right, and if I write float, then it will be converted to 15.0 and the class will be converted to float. Okay. So moving to the next, which are strings data type, which is the most used. If I write over here string conversions, right? If I write this, before going to the radio, let's go back to the slide and understand what are string conversions. String conversions are basically done using the str function. It converts values to a string, and numbers, string, boolean, and even complex numbers can be converted into their string representation, making them usable for displaying or text processing. Just let me write, suppose I write x equals to 5, right? Or just let me copy this one. Just let me copy this, and if I paste over here, then the data type of this will be float. Right? If I wanted to convert this into form of string, then we just have to replace float with str, then it will be converted in the form of string, right? Suppose if I again paste this and I write 15.5, and over there if I write an str, then it can be stored as string, right? If I again paste this one and if I write 15 plus 4j, this is a complex number. If I use string over here, then it will again be converted to strings. Okay, so any data type that easily can be converted to strings, right? If I write x equals to true, right, and if I check print x and type of x, then it will return me boolean, because we have not converted this into any string form. So if I just specify SDR before this, then it will be converted to string. Okay, so string on conversion are also very simple. It's not a huge topic. We just have to understand what kind of data types we need. Okay. Let's move to the next, which are Boolean conversions. Boolean conversion basically means converting values to Boolean, true or false. There are certain values that can only be converted to false. Rest every value in the bool conversion comes true. The first one is 0 itself, empty strings, empty collections, and none can be converted to false. None zero numbers, none empty strings, and none empty collections converts to true. In short, anything beyond 0 is considered true, right? Just let me give you an example. If I write x equals to 0, right, and if I write print x and type of x, now it will return me integer, because 0 is a whole number. If you wanted to convert this in the form of booleans, then we just have to specify the bool function. If I specify this and if I done this, then the 0 will be converted to false, right? Again, if I write any number other than 0, if I write 1 and if I specify bool over here, then it will return me true. So I just specified anything, any number other than 0 are classified as true. If I write, if I use 2 over here, if I use 2 over here, then it will again be true. If I even use 100, na, then it will return me true, because anything beyond 0 is true for booleans. Okay. Now anything other than empty string are true. If the value is passed is empty string, then only it can return false. So if I write x equals to empty string, right, nothing inside that code. So nothing, if you write nothing inside the quotation, that is referred to as empty strings, right? If I write print x, and if I write type of x, then it will if I write type of x, then it will return me string, because it's a single quotes, right? And there is nothing inside of that. That's why it's string, right? If I write if I convert this in the form of bool, then it will return me false, because it's a empty thing. Any empty thing basically means false. Okay. Now, but if I write anything, if I write bool, inside that if I write Kumod, even my name, then if I check print x and type of x, then it basically returns me true. So anything other than 0 and empty string can be classified as true while the conversion of booleans. Okay. So I hope this is clear. And let's move to the last data type conversions, which are complex data type conversion. So let's go back to the slide. Inside of that, let's understand what values can be converted to convex while using the complex conversion. Okay. Suppose if I write convert value to a complex numbers in the form of a plus bj, so basically the format of complex numbers. Integers, floats, booleans can be converted directly, right? There's no issue. But strings can only be converted if they have represent a valid real number only, or an exact complex number in the codes, which means if I come over here and if I write x equals to 4, right? And if I write print x and type of x, right? Then it will return me 4 class m, because 4 is a whole number, and it will be stored in the form of integers, because it's a implicit type casting. Now if I write complex over here and if I just pass this one, then it will return me 4 plus 0, because in the it should be in the form of a plus bj for the complex number creation. That's why if I just space a complex and 4, then it will create a plus 0j for complex. Okay. If I write x, if I write this x equals to complex, and inside of that if I pass 4 by 4, which is a whole number, and if I write print x and type of x, then it will again need it. Then it will again return complex data type, which is 4.4 plus 0 in. Okay. And if I move to the next, which is x equals to complex, and if x equals to complex, inside of this, if you pass two different values like 4 comma 5, then it will be converted to print x and type of x. If I check this one, then it will return 4 plus 5j, because the first number is classified as real number, the second number is classified as the imaginary number, which is and the class of that or the type of the number will be complex. Now there was one more important point, which was strings can only be converted if they represent a valid real number or an exact complex number in the codes. So if I write over here x equals to complex, and inside of this if I pass the only the real number in the form of strings, and if I write print x and type of x, then it will return me 5 plus 0 is a class complex. If I write x equals to complex, right, and if I pass 5 plus 2j, then it will also be converted print x comma type of x, then it will also be converted, right? But if I don't pass j, then it will throw me an error, because that's not a exact format of complex number. So inside of strings, either we just have to pass the only the real numbers or the whole number in the form of exact. The last one which is remaining is the Boolean one. If we write x equals to complex, right? Inside of that, if I pass true, and if I write blend x and type of x, then it will return me 1 plus 0 z, because true, the value of true is 1, and it will return me 1 plus 0 z. Okay. If I write over a false, then it will return me 0 z, not 0 plus 0 z, because anything in a number, if you add 0, the number will not change. That's why even in the imaginary number, if you add 0, the imaginary number will return imaginary number itself. That's why it does not return 0 plus 0 0, it just returns 0 0. I hope typecasting is also clear. Just go through a recap. Just going through a recap, we covered integer conversions, then float conversions, string conversions, boolean conversion, and the complex conversions. But over here, we just used AV functions in the independent order. But we can use same functions in the same line, which is made pretty much required in some scenarios. If I add x equals to integer uh, bool, and inside of that's complex, and if I write string, and inside of that if I pass 3 plus 4j, and if I close this much, and if I write print x, and if I write type of x, then it will return me one class int. Because just let me zoom it, and let me help you understand this. Whenever there are multiple functions used, the most thing we use the executor is the innermost. The innermost is string, right? So it will convert 3 plus 4j in the form of 3 plus 4j, okay, right, in this form, right? After that, this complex will run, and it will change this in the form of 3 plus 4j, right? And after that, the pool will convert. Then after complex, the pool will run, and it will return this anything pass inside the pool other than 0 and empty strings are true. So it will return true, right? And after bool, the integer will take place. So any the value of true in the form of integer is 1, right? So that's why it's returned 1. And if you check the type of this x, because one is being stored in the x, if I check this, then it will return me integer. Okay, I hope this is clear. We can use any functions or multiple functions as well during the type conversions, which are pretty much required when we build our own logic inside of loops, functions, and it they are basically used to overcome the type error, value error, and many more different things. So just let's go back to the slide, and let's understand what is the role of correct data types. Okay, so the role of correct data type is that using the right data types ensures programs run smoothly without any errors. Okay, arithmetic operators need numbers, right? So converting those strings in the number before performing arithmetic operation is crucial. Okay, and it can be used for text handling, need strings. Typecasting helps match values to the correct data type, avoiding errors and making program reliable. So let's go back to the practical, and if I write just let me copy the first code which we just did on class to understand type conversion. This one, right? Suppose if I come down, and if I run the same thing, suppose if I run the same thing, we get 23, right? But we are performing arithmetic operation, so this should return me as 5, right? So if I convert this in the form of integer, right? If I convert this in the form of integer, and if I write this, then it will return me 5. And if I check the type of this one, if I check the type of extra, then it will return me integer. So I hope type conversion and or typecasting is clear in Python. It is a fundamental of any logic building, any type conversions, which is very crucial for explicit typecasting, as it helps us in reducing type error, and the second one is the value error, right? The typecasting helps us to overcome these errors. The first one is type error, and the second one is value error. Okay, so typecasting is crucial in Python or even in other programming. It's crucial. So that's all for today's session. We'll be covering a new topic in our next class.